Good morning to one and all person here. I am Dr. M. Charles Robert, Associate Professor, PG and Research Department of Physics, HKRH College, Uttamapalli. Today I am going to present a seminar on the topic clippers using the diodes. Before going to deal with the diode as a clipper, I would like to give some introduction about the diodes. So diode is simply called a dielectrode, having two electrodes, anode and cathode, using two semiconducting materials, one as the p-type semiconducting material and the other one as the n-type semiconducting material, which are sandwiched together forming a junction called p-n junction. This junction is also called depletion region as the charges are depleted, or a charge-free region. And this diode has holes as the majority carriers in the p-type and electrons as the majority carriers in the n-type. And this diode can behave in two different ways. It can behave in a forward biased or reverse biased condition as shown in the animation diagram. When the diode is in the forward biased condition, the depletion region normally, width of the depletion region normally decreases and the charge flow is possible if the applied voltage is greater than a voltage called a knee voltage. This voltage may be around 0.3 to 0.4 for germanium and 0.6 to 0.7 for silicon. And when the diode is in the reverse bias condition, the width of the depletion region enhances or increases, and thereby the charge flow will be stopped. Therefore, there is no flow of current in the circuit. Now, based on this idea, the clipper circuit are being designed. They are the wave shaping circuits that can control the shape of the output waveform by removing or clipping a portion of the applied input wave. Now, these have so many applications in the half-wave rectifier, full-wave rectifier, voltage limiter, amplitude selector, slicers. They are all used in various digital computers, electronic systems, etc. Now, there are different types of clippers. The basic clippers are two types. One is the series clipper and shunt clipper. And the series clipper is also classified into four categories: are the series positive clipper, series negative clipper, series positive clipper with biasing, series negative clipper with biasing, and the same like in the case of the shunt clipper circuit. In the case of series positive clipper, the circuit is being a simple circuit, and this is the input source given, a sine wave. And when a positive cycle of the input goes to this circuit, this diode will be a reverse bias, and there is no current flows through this diode, and then there will be no voltage across this R or at the load output. Thereby the positive region will be completely clipped. But when the input is in the negative going cycle, then this acts as the forward bias and the current flows through the circuit, and thereby a voltage will be generated that is equivalent to the applied voltage. Therefore, you have only the negative portion available, the positive portion is completely clipped. Now, this is a positive clipper with the different biasing voltages. For example, this VB is the biasing voltage, and when this input voltage is given, based on the biasing voltage, the positive region will be clipped above the VB voltage and the remaining will be the output voltage. In the case of the positive clipper with the negative biasing, here also the same logic will be applied. Based on the applied voltage VB, the negative portion will be available in the cycle. This is a series negative clipper. Here also the same logic. So the negative portion of the input voltage will be clipped, so that we will be getting the output voltage only positive. So these are the two types, just like as we have explained earlier. And this is something called the shunt positive clipper. Here also, when during the positive biasing, positive voltage, the diode will be in the forward bias condition, and when the diode is in the forward bias condition, the voltage across the diode is only very small voltage. There is a new voltage around 0.3 or 0.7 depending on germanium or silicon, and hence during the positive biasing, positive input voltage, the voltage across the diode will be the output voltage. There is very small voltage, or approximately, ideally speaking, it is 0. When it is being the negative going cycle, the diode will be reverse bias and the current will not flow through the diode, and the current will through R and the load resistor RL, and applying the voltage divider, the output voltage will be V input into RL by R plus RL. That is the output voltage. So the same logic will be applied for the biasing with the VB values. This is the same circuit like the negative clipper, and the function is almost same like the positive clipper as mentioned earlier. And this is the shunt negative clipper with biasing, two important circuits. Based on the selection of the VB value, we can choose any values which can be clipped in negative side. And this is an important circuit called dual clipper, in which we are using two biasing voltages VB1 and VB2. So depending on the value of VB1 and VB2, the upward portion and lower portion, that is the positive portion and the negative portion of the input signal will be clipped, so that you can get a dual output. That is now this can be useful for the production of various type of signals. Thank you.